Lesson 2-3, solving multi-step equations. It's starting to get a little more complicated today, moving up to 3 and 4 step equations. And I'm back here with our equation machine again, so that you can once again see what's happening to the variable. So let's look at it going forwards again. We take our number x, right? And in this equation, 3x minus 5 over 4, all over 4 equals 13. The first thing that happens to x is that it gets multiplied by 3. Right? And then after that, 5 is subtracted from it. And then after that, the whole thing is divided by 4, and we end up with 13. So if we go back to what we were saying yesterday, that we need to work backwards, then we're going to start with the last part, which is the 13. And then we're going to do everything in reverse order and the opposite operation. So the first thing that's going to happen to my 13 is that it's going to get multiplied by 4. Right? And then 5 gets added to that. And then lastly, right, that whole thing, which was originally multiplied by 3, gets divided by 3, and that will give me x. Right? So I work backwards, undoing every operation that I see, right, and doing it in reverse. So let's give it a try. Actually, let's look at a few steps. Now, today's notes don't really have anything to write down specifically in the book, so you're going to write this down below the box in the middle of page 24. Okay. What I want you to write down is the stuff on the bottom half of the screen. So we know that if the equation has several operations, then it's going to take several steps to solve it. We're making equivalent equations at every step, and we're always going to write those equivalent equations. Things that you might have to do. You might have to distribute to get rid of the parentheses. You might have to divide to get rid of a number next to parentheses. Okay. You might multiply to get rid of the number in the denominator. You might need to combine some like terms, variables and or constant terms. Now, that is not a list of things you have to do in order. Right? Every problem is a little bit different, and one of the things about algebra is that you're going to really feel like you're building a toolbox of skills that will allow you to solve a wide variety of equations. So these are all kind of things to put into your toolbox. Maybe I'll distribute, maybe I'll divide, maybe I'll multiply. Just have to wait and see what the problem is, and then kind of scope it out when you get to the problem. Right? You got to use your brain and be flexible. Remember, you can pause this if you still need to write down more. Here's our first example. Solve 8x minus 21 minus 5x equals negative 15. This can go in the box in the middle of page 24. So I don't see any parentheses. I don't see anything that needs to be distributed, but I do see some like terms. I see an 8x and negative 5x, both on the same side of the equation. So I want to combine those two things. Right? And feel free to zip zap, adding the opposite anywhere you see subtraction, just so that you know exactly what you're getting. Especially if you like to move things around, it's really important that you make sure the negative is attached to the number, right, and that you don't forget about it when you start shifting things. So we got 8x plus negative 5x is 3x's plus negative 21. Oh, and now look, how nice is that? I have a two-step equation. So it really just took me one extra step to get back to something that I'm actually totally familiar with. So now I'm just going to add my 21 to each side. And that leaves me then with 3x's equal to negative 15 plus 21 is 6. And then I can go ahead and divide both sides by 3. And I get x equals 2. And I'm going to quickly check in the original problem, not any of your steps along the way. So I get 8 times 2 is 16 minus 21 minus 5 times 2 is 10. And I am going to zip zap again just to make it a little easier. So 16 plus negative 21 is negative 5 plus negative 10, which is negative 15. And so I know I have the right solution. Remember, it's fine to use a calculator to check your work. Okay? It is definitely worth taking the time. You can always tell if you get the right answer to an equation because it's easy to check. Let's try another one. Okay. This time I have a big fraction, has an expression on the top, 3 on the bottom, and that whole thing is equal to 7. Anytime you have a single denominator and more than one term on the top, it's usually a good idea to just get rid of that denominator by multiplying both sides by the denominator, right? So we get our fancy form of 1, our foo, right? And so this 3 and the 3 in the denominator cancel out. I don't really have anything to distribute. All I'm left with is actually 2x's plus 1 equals 21. Subtract 1 from each side, and I'm left with 2x's equal 20. Divide both sides by 2, and if 2x is equal 20, then 1x has to equal 10. Some of you were able to probably figure that out from the get-go because you knew that the top had to equal 21, and if the top had to equal 21, then x must equal 10 in order to make that happen. Okay, so we can definitely see that it's right. 2 times 10 is 20, plus 1 over 3 is definitely 7. Okay. You could break it up into two fractions, 2x over 3 plus 1 over 3, but I think most of us are generally trying to avoid fractions whenever we can, so multiplying by the denominator is definitely an easier way to go. Okay. Don't forget about those negative signs. You can always remember that you can stick a 1 in front of it so that it makes it easier to remember to distribute it, because you do have to distribute that negative sign. This comes into play when we subtract something that's in parentheses. So here we have a problem with distributing. You only had room for 2 examples in your box, so find someplace below there on page 24 for this example. And I'm going to show you 2 different ways to do it. So let's draw a line down the middle here. One way to do this problem would be to distribute. Right? So I'm going to take my 5 and I'm going to distribute it across both the p and the negative 2. And I get 5p minus 10 equals negative 15. And now I have a 2-step equation, so I'm going to solve. Right, add 10 to both sides. 5p's equal negative 5. So dividing both sides by 5, I get p equals negative 1. And it's up to you whether you continue to always write down what you divide by or not. What I really want to make sure that you're showing are the equivalent equations. So I want to see that, I want to see this, and I want to see the answer. Hope you can see that yellow on your screen. It's a little hard to see up here. Okay. Now the alternative, right, would be to take that 5 and go ahead and divide by it. Okay. I'm going to rewrite the problem here so you can see that. Because 5 very nicely goes into 15. So I could take the whole equation and I could divide it by 5. And that makes this 5 disappear. And I'm left with p minus 2 equals negative 3. Add 2 to each side, and I get p equals negative 1. Right? Same answer both times. Right? Your choice whether you distribute or go ahead and divide both sides. Usually I decide based on whether the number on the outside here, this 5, whether it divides nicely into this number. Okay, this is our last example for today. Now this goes along with that slide 2 slides ago where we had that stuff about the negative. So we got to be really careful here because this whole thing, the 4y plus 8, that's all subtracted. So let's change this to plus negative 1 and go ahead and distribute that negative 1. And we get 10y plus negative 4y plus negative 8. Do you see how the 8 is negative also? Right? So because I was subtracting it, it ends up being negative. Now I can combine my like terms, right? And I get 6y's plus negative 8 equals negative 20. Add 8 to both sides, and I have 6y's equal negative 12. I'm almost going to run out of room here. Divide both sides by 6, and I get y equals negative 2. Let's quickly check it. 10 times negative 2 would be negative 20 minus, right, 4 times negative 2 is negative 8. Always go back to the original problem. Oh, negative 8 plus 8, well that's nice because that's just 0. So all that would be left then is negative 20, and that's what it's supposed to equal. Pretty convenient. That's it for lesson 2-3. We'll do some more examples together in class to clarify anything you're confused about.